Number 3, it asks, it asks that the removal should be larger. So for CO2, it should be higher than 0.8. And what measures can we take? So what can be done and what are the advantages or disadvantages of this measure? Well, question 3. Removal efficiency. Oops, the other way. We can increase the removal efficiency of CO2 by setting up a counter current flow. In the tower aerator. And you will find if you use the equation, so we know that for co-current you use K3 and for counter current you use K4, and if you calculate these two you'll get, so co-current we have an efficiency of 0.8, but using counter current, in fact, we will get somewhere close to 1 removal efficiency. And you can use it. The calculation, the formula is as follows. One minus e to the power of minus k2t times 1 minus, so be careful, this is a minus, not a plus like we see in K3, kd divided by rq, and then you divided all that with 1 minus kd over rq. Again, this is a different one. You then multiply it again with the exponential of almost close to the top part, minus k2t times 1 minus kd over rq. Again, watch out for the additions and the subtraction signs. So if we substitute the same numbers of k2t of 10, rq of 5, and kd of 1.3, you will have an efficiency of close to 1. So this is using the counter current. However, there are disadvantages. So we have to be aware of the disadvantages of using a counter current. So although you are increasing the removal efficiency of CO2, this negative impact that it has is, first of all, it causes limestone scaling because you're removing so much of the CO2. You're removing almost all of it, basically. So that causes limestone scaling because you don't have enough CO2 in the water. And then you also can have flooding at particular times. So it's a compromise, really. If you want to use co-current, you have a moderate removal of carbon dioxide. However, you do not have the problems that are occurring with counter current systems, which is limestone scaling or flooding. So that was question 3.